It is given that y is the natural log of 4x squared take away 1 over x plus 2. We want to find the values of x for which y is not defined. Now, an obvious one straight away, we're not ever allowed to divide by 0. So x equals -2, and I'll put an explanation there, would make the denominator 0. We also know that we cannot take the log of 0 or anything negative. So we have to have that 4x squared take away 1 is greater than 0. So that means that 4x squared needs to be greater than 1, which means x squared needs to be greater than a quarter. So if we now consider x squared equals a quarter, that would mean that x is equal to plus or minus a half. So in order, let's just think about this. Here's x squared, and a quarter would be like this. And of course x squared, this would be the x-axis. This is the line y equals a quarter. And so to be bigger, it needs to be this way from negative a half and this way from a half. So x cannot be between negative a half and a half, inclusive. It can't be those either, because if x squared is a half, x squared is a quarter, and that would actually give me log of 0, which is undefined, so we can't do that. So altogether, we cannot have x between these values, and we can't have x equal to -2. So we now want to find dy dx. So I'm just going to write y down here so I can scroll the screen up. So we've got ln 4x squared take 1 all over x plus 2. So this is a quotient. So I'm going to say u is equal to the natural log of 4x squared take away 1, and v is equal to x plus 2. So du dx is going to be 1 over 4x squared take 1 multiplied by the differential of the inside function, because we have to use the chain rule here. So that's 8x. So that's 8x over 4x squared take 1. dv dx is just 1. So that's nice and easy. Then dy dx is v times du dx. So that's 8x x plus 2 over 4x squared take 1. Take away u dv dx, so that's ln 4x squared take 1 all over x plus 2 all squared. So we could write that as 8x x plus 2 take away 4x squared take 1 ln 4x squared take 1 all over x plus 2 all squared 4x squared take away 1. And looking at the mark scheme, they were happy with this as the answer. They didn't need the simplification I gave here. So what do we now need to do? Find the approximate increase in y when x increases from 2 to 2 plus h. So we'll have x equals 2, and the change in x is equal to h. And we're required to find delta y. Well, we know that delta y is approximately dy dx multiplied by delta x. And in this case, that's going to be dy dx when x is equal to 2, and then we're going to multiply that by h. So if x is equal to 2, what is dy dx? So delta y is going to be approximately, so x is equal to 2, so that will be 16 times 4, 64. Take away 2 squared is 4 times 4 is 16, take away 1 is 15, ln 15, over 2 plus 2, 4 squared, 16 times 15, so that's 64 and times h obviously, 64 take away 15 ln 15 over 16 times 15, which is 240, times h. Now the mark scheme actually calculates this value, so I suppose we should, just to make sure that we've actually got it right. So that is 64 take away 15 times the log of 15, and we're dividing by 240. That gives me 0.097, shall we say. And what does it say on the mark scheme? So here it is, 0.0974 h. So that is correct.